Good morning, everybody, and welcome to MTM Critical Metals Investor Presentar, talking through their Flash Joule Heating technology. Before I introduce you into the team, just a quick housekeeping matter. There'll be a presentation from the MTM team, followed by the chance to ask questions. To pose a question, please just type it into the Q&A facility at the bottom of the screen, and I will read that out to the team. With that, I'd like to hand you across to John Hannaford, who's chairman of MTM. John, over to you.
Thanks, Craig. Good morning, everybody. Thanks for your interest. We'd like to really delve into the FJH technology that MTM has invested in. For those who don't know, MTM Critical Metals is a rare earth exploration company that invested in this breakthrough Flash Joule Heating technology through a license agreement with Rice University in Houston. And we're, with this presentation, outlaying our strategy for expanding the areas of which we are applying the technology, and also the opportunities that are ahead for the company. But also, as part of this, like to introduce some much more technical minds than I involved with the company. Steve Ragiel, who is a chemical engineer with 30 years plus experience in developing technologies, and particularly for us in relation to recycling, and that's one of the areas that we are addressing with the Flash Joule Heating technology. The other gentleman, Michael Walsh, will come in later, particularly around the discussion about lithium. He is another chemical engineer, an MBA with 15 years plus experience in a major mineral processing house that has designed many of the major lithium processing and rare earth processing plants in Australia. So I'll just an overview. We'll move to the next slides. Thanks, Craig. And I'll let Steve jump in a minute. But just this is really what the Flash Joule Heating opportunity is, and we're highly excited by the applications that are potentially available to the company. We initially licensed 4 applications from Rice University in relation to extracting critical metals from waste materials. And so those are mainly red mud from bauxite processing, coal fly ash, e-waste, and lithium-ion batteries. We subsequently added another string to our bow, or several strings to our bow, with looking to apply the technology to mineral processing. That's more upstream in the mineral cycle, and that's where we've seen today's announcement of a significant testing results in relation to lithium recoveries. We'll get to that later, but I'll let Steve just introduce himself firstly, and also look to just discuss the Flash Joule Heating technology opportunities.
Thank you, John. I appreciate it. And thank you, everyone, for joining in the webinar. As John mentioned, I have 30 years experience in the recycling space, building up companies from the ground level, zero revenue, up to the $800 million level. I've built plants in the US and Australia and Europe and Asia. As John mentioned, my background is in chemical engineering, and I've been commercializing a number of technologies into the recycling industry. And now I'm working closely with the MTM team and Rice University here in Houston, as well as Nighthawk Engineering here in Houston, and our other strategic partners on commercializing the technology. As John mentioned, there's 2 key areas that we're working on. One is materials from waste dumps, from waste material, and then ores and mineral deposits. They're both very interesting, with a very high value in the market. We've estimated over $200 billion in market size, and more importantly, each one of those markets is growing quite quickly. As John mentioned, we're working on extracting critical metals from waste materials such as red mud, which is the residue from producing aluminum from bauxite, as well as from coal fly ash. The other interesting areas on the waste side include recycling of electronic waste from waste computers and cell phones, and as well as recycling lithium-ion batteries. The other positive thing that's going on here is our ability to extract value from deposits that have otherwise been previously considered uneconomic. We'll describe more of that as we go along. and basically providing low-cost sources of critical metals. So we're working to revolutionize process flow sheets and disrupt the state-of-the-art approach with our Flash Joule heating technology. And we're working with industry to help solve key supply, environmental, and recovery challenges. Craig, we can go on to the next. So the core part of the technology is the Flash Joule heating, which makes use of the Joule law of heating. In effect, we're applying a very large electrical charge across the material that we are treating, and the material acts as a conductor. And the resistance of the material creates heat, and it creates heat very quickly. We get up to 3,000 degrees in milliseconds on some of the flashes. So this creates some very interesting physical and chemical transformations, which are potentially very beneficial for metal recovery. Craig, we can go to the next. A couple of our key partners include Rice University. Dr. James Tour and his team at the university have basically pioneered and originated the Flash Joule heating approach to a number of manufacturing technologies. A couple of these are fairly advanced now in terms of manufacturing graphene and nanotubes, and we're coming along very quickly behind those to ramp up and scale up to commercial and semi-commercial scale our processes, working hand in hand with Rice and the Rice team, and the enhancements that they're working on continuously on the patents and the technologies associated with the Flash Joule heating. We've also started to work with Murdoch University, which is an excellent complement to the Rice University team based on Murdoch's expertise in metallurgical processing and some of the things that are going on with the phase changes in the metals as we apply the Flash Joule heating. Another partner is Nighthawk Engineering here in Houston. They have great expertise in scaling up technologies to semi-commercial and commercial scale. And they have an extended team of chemical engineering, mechanical engineering, controls, and other sectors that are bringing the scale up of our technology into reality. Craig, we can go on to the next. So as we mentioned, two of the key areas of sourcing valuable and critical metals are from waste materials as well as from ores and minerals. So on the e-waste side, the spent batteries, the lithium-ion batteries, the coal fly ash, and the bauxite, there are critical metals, precious metals, and rare earths that are all available for recovery. And our technology is making it more economic to recover those materials. And then on the mineral processing side, as John mentioned, we announced today our work on the spodumene. We are seeing very interesting results on the recovery of lithium, rare earths, precious metals, including gold and niobium. Thanks, Craig. As John mentioned, a number of the materials that are contained in assets that MTM has under its control are being tested for rare earths and niobium. And we're also working in adjacent spaces on other ores and minerals. So the metal on the metal side, from bauxite, there are things like iron being removed, aluminum being recovered, titanium being available for recovery, and other rare earths from the coal fly ash, as well as the heavy metal removal from coal fly ash. And then on the e-waste side, significant value there as well. Go ahead, John.
Just what's really interesting from our journey so far, and we've only really just began completing the acquisition back in March this year, but we're now being approached by a number of different groups, and a lot of them have very valuable deposits, but they can't liberate any value. For example, there's tailings dams running 6% total rare earths. There's mineral processing bottlenecks and side products being produced that are inefficient and sitting there as unrealized value. We're also working with other groups where they want to see if we can try to synthesize a product out of wastes. So it's not just limited to things that we have on our table. This is we see the way forward and under this business units as being people and companies approaching us, and we're already well on the way with some partnerships in that ground. And I think having the two universities as partners, we get a lot of industry players who are already talking to those universities for assistance in terms of unlocking chemical and I suppose some of their processing issues to try and liberate value and make processes quicker. So it's via those university partnerships that we're seeing a lot of opportunity come to us, as well as us working on our existing projects. So really exciting how this might materialise in terms of licensing out to some bigger players, as well as producing our own products potentially.
Very good. Thank you.
Next slide, Craig.
Yeah. So I had mentioned a little bit earlier, the addressable market is in the range of $200 billion today and growing quite quickly. And we believe it could be significantly higher than that in the next 5 or 6 years, including the electronic waste in the $50 billion range, growing to $90 billion, and the battery side at $10 billion up to in the range of $60 billion. And then on the mineral side.
Sorry, Steve, one thing that's interesting there is e-waste, just in situ value of some of the e-waste componentry that is being thrown away basically and put into landfill is a higher grade in a collective metal sense than many of the primary ore deposits that are being proven up and explored and produced. So it's existing deposits, if you like, that are of critical metals that are sitting being thrown away or unutilized, and that's where we see a massive opportunity. So we get the parties together to reduce the waste, but also to try and create an outcome and provide sources of critical metals for industry and countries. That's, I think, one of the original tenets of the Rice foray into this space with FJH was to try to secure critical metal supply for the US government and US interests. So I think there's a lot to play out here, and the value of what's already there as waste can be quite significant.
Absolutely. And just one example on the battery waste side, we're working with a group that has a hydrometallurgical process, and there are definitely areas for improvement in terms of the yield and the amount of reagent and the amount of heat that they have to use to recovery the critical metals from the batteries. Right, can we go to the next? So, key stages in our development for creating value for MTM. Technology leadership, we have that and we're maintaining that. There are additional enhancements to the patents with Rice University that will be coming out over the next couple of months. We're working on multiple strategic partnerships with tier 1 global mining and chemical companies. And we also are working with a number of different government entities to push forward on the funding side to develop access to these critical materials that in some cases are in strategically undesirable locations. And then, as John mentioned, one key point of revenue creation will be the licensing income with these strategic partners that we are working with. So on the technology side, we've licensed a number of patents from Rice University. There are a number of enhancements that are coming along directly behind that will come about here in the next couple of months. On multiple fronts, we're working with strategic partners that are in the mining business globally and or the chemical industry globally. And they're very interested in both the direct value creation from reducing the amount of energy and heat required for the processing, as well as the additional value for reducing the amount of reagents and the amount of byproducts that are created. John, did you have something you would like to add to that?
No, I think that's good, Steve. I think we'll move on to the next slide there.
So
So
we have a.
go on.
No, go ahead, John. You
Yes.
take it.
This gives a bit of an update on where we're at. We're well advanced in terms of testing several of the samples in each of the industrial waste categories, with more to come. And on the mineral processing, that's well advanced as well. You can see there's both rare earths and lithium. It's in progress, and certainly some different rare earth opportunities from different companies are being presented to us, and as well there's others that we haven't tested yet. So a lot underway at the moment, and this will see a lot of potentially step change activity coming through the market, as well as results from testing. So I think what is one takeaway from that is today we've got a lot happening, and there'll be a lot of news flow, which we think will be very favourable for where the market is over the next 3 to 4 months.
Greg, can we go to the next slide? Okay, I think Michael.
Yeah, I'd like to hand over to Michael. Just behind this, Michael's been involved with the company in the background, I suppose, for a while. He's got a very high level of technical expertise in this space, and it introduced, I suppose, the concept of the lithium opportunity to us several months ago, and that's followed up now with us being on the cusp of a major discovery, a major technological breakthrough. And I think Michael can just a bit of background as to where you are, Michael. But he's joining us as a technical advisor at the moment. But he's really a main driver into this mineral processing space.
Yeah, thanks, John. So yeah, now I'll provide a short overview of what I believe is the most exciting and potentially lucrative opportunity for Flash Joule Heating, and that is improving how refractory minerals are currently processed. Myself, I've got quite a long history in minerals processing and also process heat transfer equipment, and I genuinely believe that this Flash technology has the potential to disrupt incumbent technologies. The big picture opportunity here is to address energy usage and CO2 emissions in the mining industry. The mining industry, as probably most people would be aware, is a major consumer of energy, and it's also a significant CO2 polluter due to its reliance on fossil fuel derived energy. And anyone who's ever been to a mine and processing plant will see this firsthand. Therefore, it's quite a worthy cause to try and improve these metrics, and it could be potentially very lucrative for a company like MTM. Because most mining companies will have initiatives underway to tackle these issues, and any kind of potentially disrupting technology would be of interest to them. Next slide, please. Yeah, so when I was first introduced to the FJH, the first potential application that I thought of was in the treatment of lithium, and specifically in the downstream treatment of spodumene concentrate. Many Australian investors will be aware of what spodumene is. It's a mineral that's currently the world's largest source of lithium globally, and there are several active spodumene mines in Western Australia that currently produce a 6%, 5 to 6% concentrate. Most of that concentrate is shipped to China for downstream refining into a more finished product, lithium hydroxide or lithium carbonate. But there are also more recently refineries that have been built in Western Australia. The image here shows one of those, and the photo here shows 4 horizontal rotary kilns. Now, what are those kilns for? Well, spodumene is a very refractory mineral, meaning that it's really challenging to extract the lithium from it, because it's the lithium atom is so tightly bound to the other atoms in the mineral. Even the strongest acid won't dissolve that in its natural state. The technical term for it, the natural state, is called the alpha polymorph. Next slide, please. And in the 1960s, a process was developed that involved a very high temperature treatment. The technical term again here is called calcination. So that's heating it for over 3 hours at over 1,000 degrees centigrade to get that refractory alpha spodumene to essentially expand and turn into its beta polymorph, which is amenable to acid leaching. And the potential here for Flash Joule Heating is to either complement or eliminate entirely that very energy intensive calcination step. Next slide, please. Next again, please. So after the calcination step, there's another kiln step called roasting. And here both high temperature and acid are used to solubilize that lithium and get it into a more convenient form for the downstream refining. Now, what MTM is aiming to achieve here is trying to improve those two high temperature kiln based processes. So the calcination and the roasting. Now, the rotary kiln itself is a very old process technology. It was developed around the Bronze Age. And I personally have worked in with rotary kiln design in the past, and I can tell you that it's quite a thermally inefficient piece of kit, but it is the workhorse of the industry, and it's widely used in lithium refining, rare earth refining, and cement manufacture, for example. And really, it hasn't really changed in several hundred years. Another aspect that current horizontal kiln technology, the drawback is that it only can use fossil fuels to generate that heat energy, and therefore is always going to generate high carbon emissions. And here's the typical flow sheet, and this is the flow sheet for turning the spodumene ore at the mine into a finished battery grade product, lithium hydroxide. And so why is MTM trying to focus on those two kiln steps? Well, it'll be obvious when you see the next slide, please. So it's all about energy and CO2 emissions. So including mining, crushing, grinding, etc., by far the highest energy consumption for the entire process is the calcination step. It's roughly about 50% of the entire energy used to produce that battery grade product. And I can guarantee you that all lithium producers and battery makers will be focused on reducing steps like this, because essentially they're all going to have to adhere to the battery passport that places like Europe are going to enforce soon. That's where essentially that they're going to have to be adjudicated on the CO2 intensity of their product. And a price penalty could result for those that are above a certain threshold. So I guarantee you that any lithium refiner will be definitely focused on trying to improve the energy consumption and CO2 emissions of their process. Next slide, please. And now I suppose hot off the press is the announcement this morning that the very encouraging preliminary flash tests were undertaken on spodumene concentrate. And the purpose was to determine, is there any merit in trying to compete with that calcination process, or in the technical jargon, trying to transform the alpha to the beta spodumene. And very positively, yes, the material did in fact undergo alpha to beta calcination. Now that process typically takes up to 3 hours in a conventional kiln. And these initial flash tests showed that essentially the same result can be achieved after only about 14 minutes of flashing, which is, as you can imagine, a really significant time saving, 92% reduction. Those results are very preliminary and unoptimized, but it essentially reinforces the hypothesis that Flash Joule heating could potentially be a game changer in this lithium industry. And that success also provides confidence for the MTM team to examine other refractory minerals like rare earths, niobium, etc. So the scope here is really huge. Next slide, please. Now, the potentially even bigger prize here is the target, to try and target spodumene material that's currently discharged to waste tailings. So a couple of images on the slide here show two big lithium operations in Western Australia. As you can see, both have quite large tailing storage facilities. Next slide, please. And in the typical flow sheet for spodumene recovery, up to over 10% of the ore will actually be discarded to tailings because it's essentially too fine to recover. And again, the culprit here is the calcination kiln. If you put that fine material into the kiln, it forms clinker, it sinters, and essentially is unrecoverable. So the default process here since the very beginnings in the 1960s has been to just discard this fine material to tailings. And I see here the opportunity for Flash is really very large, because if you can essentially treat this material, there's potentially millions of tons of residual value in all of these lithium operations that have been operating for decades. So that's where I believe the real prize is, that now that they've proved that this Flash can do that calcination, then I think the next step will be to target tailings. So very big opportunity here for Flash Joule Heating, in my opinion. Next slide, please. Look, I won't dwell too much on this next slide, but essentially the same fundamentals here apply to rare earths. So rare earths, again, are notoriously challenging due to the refractory nature of the minerals involved. And again, they use kilns to crack open the mineral to get them to be more acid leachable. And I think the next step for MTM, now that it's worked on spodumene, the next step is to target rare earths. And here is a photo of a cracking rare earth facility that's being built in Western Australia. And I think, yeah, it's the next opportunity here is very big for rare earths. And I'll finish up here. I think there's a couple of more technical slides, but that's essentially the opportunity. I personally believe this is the biggest avenue for commercial success for the Flash heating. Over to you, Steve.
Thank you, Michael.
Let's go through those. Oh, here we go.
Yes, so just to reconfirm, we have disruptive technology, which is very much focused on a non-traditional provision of heat to save on the energy side, as well as on a parallel basis to save on the amount of reagents and acid that's needed for the processing, the time needed, and the CapEx needed, as well as the reduction in byproducts, including CO2 and other emissions. We are working with a number of tier one global mining and chemical companies on developing the Flash Joule for their processes. And we're seeing interesting results with all of them. So we'll continue to press forward on those. And there are a number of government entities that we're working with as well that are interested in securing critical metals and critical materials on a more domestic basis in Australia and the United States, which we are also working with. And as you've seen in our presentation today, we're broadening out to include the ores and minerals and the materials that are contained in the MTM assets and other adjacent material streams. So we're broadening out into both the waste, recovering metals from the waste streams, as well as recovering metals from the ores and minerals. Craig, yes, thanks. John, did you want to take this last slide?
Yeah, sure. So all that activity, I mean, we've been in mid testing phases, and that's taken a little bit of time to get going with some of the protocols to make sure our testing has the right backups, as well as the benchmarks to test against. But that's now in full swing. So the ongoing testing results will come through in batches, I suppose. But I think that as Michael said, the improvements in the mineral processing applications is a real new application for us. I think just to back up there, Rice's main core competence is more around semiconductor related technologies, and as they're moving themselves into a new world of opportunity, I think having Rice and Murdoch in collaboration, and Murdoch being an expert in some of the mineral processing, metallurgy applications, I think there's a lot that can come out of that. So we're really excited that they're now openly collaborating and looking to discuss a lot of the technology opportunities. And so part of that, expanding those collaborations, both with the universities, but also with some tier mining and chemical companies that have relationships already with the universities, but also we've reached out to directly and have also reached out to us. And we're seeing some of that get through the detail and now looking to go live. So that's very exciting, and some major opportunities there, both in Australia and in the US, and some of them happening in Houston, which is kind of pretty good for us because that's where our partnerships are as well. The advancing the prototype. We have a program at the moment with Nighthawk to design and construct a 1 ton a day plant. So that's going from a bench scale to a lab scale, I suppose, up to a 1 ton a day plant, and we think that that's going to have some commercial scale opportunities, as well as a demonstration style for some of the bigger companies. And we'll be looking to get a lot of that development funded, moving on to strategic funding both in Australia and in the US. We're well underway with some of that grant process, and we see a real US-Australia alliance to try and fast track some of those opportunities, really around providing critical minerals for our partners, accelerating R&D, and we think that having an R&D base here in Australia as well, we can avail ourselves of some of the R&D funding, and I think as well as some of the expertise, and then market expansion, looking at new verticals and applications. As I said, there are opportunities that are coming to us. There's some that we don't even know of yet, which will become more apparent as we move forward. But with a view that through a number of different partnerships and licensing arrangements, we'll have a sustainable recurring revenue business model. So I think there's a lot to happen here. We really in the early stages, but we see this FJH opportunity really accelerating, and I think today's announcements are real underpinning of what we see the future looking like, and we hope to bring more good news to the market shortly. I think, Craig, if we open up for questions, if there's any from the floor.
Thanks, John. Thanks, Steve. Thanks, Michael. Just a reminder to the audience, if you'd like to ask a question, please just use the Q&A facility at the bottom of the screen and type in your question. First one that's come through is, how unique is the FJH technology? And can you talk a little bit around the IP protection around that technology, please?
Steve, do you want to take that?
Yeah, so the IP protection is based on the patents that have been put in place by Rice University, which we have licensed. We signed up the license for applying Flash Joule technology to the streams, like the waste streams of the red mud from bauxite, the e-scrap, computer scrap, scrap batteries, as well as all ores. And we have that on a global basis. There are some follow-on enhancements to the patents that are coming as well that we're working on with Rice, where that will add further protection to the overall technology.
Thanks. And follow-up question for that: how long does the license last for? Is that into perpetuity, or is there a set number of years for that license?
I believe the license goes on until the patent, the last patent that's applied for and granted runs out. So it has a very substantial length of time to it.
Right.
Part of the agreement, part of the agreement there is that we have certain deliverables with regard to Rice, and I think we're well ahead of the game in terms of that. But that just prompts us to be more active. I think it's fair to say that we've got a very good relationship with Rice. They are delivering additional opportunities under that license agreement, which we hope to finalise shortly. Just enhancements, I think, on some of the existing tech and some things that they've been working on subsequently as well. So I think that's very sound in terms of the protection of that IP, but we see it only growing as an opportunity.
Thank you. Next question is, can you talk a little bit about the pathway for moving up from the testing you're doing at the moment towards pilot stage and then into sort of more of the commercial? What are the steps that you need to go through to continue to prove the technology?
John, I can go ahead and take that.
Yeah.
So we're working daily with Nighthawk Engineering on laying out all of the design parameters for the 1 ton per day unit. And we expect that the construction of that will occur towards the end of this year and early next year. I also wanted to mention that in some of the target critical metals that we are looking at, on the government side, they see the 1 ton per day as actually a commercial sized production facility based on the material available that they're targeting. So the 1 ton per day unit is semi-commercial for some of the applications and commercial for the others.
Thank you. And is there an opportunity to potentially bring a plant, one of those pilot plants down to Australia whether it be with Murdoch University or somewhere else, given the propensity of or the high level of lithium ores out of Australia?
Absolutely. That's one of the things we're working on with Murdoch. Murdoch, I suppose, building a new campus for mineral processing down near Rockingham, which is a refurbished old campus, but they've laid out the I suppose a pathway for us to really reside in that facility and have access to their some of their technology and people, as well as just the lab space. So we're just working on that with them, but I think ideally we would have a testing facility in Perth, which we can use with a lot of the know-how and service providers that are very experienced in that space, as well as some of the opportunities with the mineral processing in terms of lithium, the red mud opportunities here, as well as some of the rare earths. And so I think that's a logical step for us. So we're just working around how that would work, and obviously one of the things we'd like to do is get some government funding to put it together. So look, we're not yet there, but you're right, that'd be an ideal next step for us to have two zones of R&D, and we get the R&D credits here in Australia as well.
Thanks, Sean. You mentioned government funding. There's a couple of questions that have come in around that. Can you just elaborate a little bit more what sort of funding you're looking for? Is that under the Inflation Reduction Act? Is that under some other form of decarbonisation? Just where are you sort of looking to for that grant funding?
Well, there's a lot of different sources. I think both in the US, Steve's very close to a couple of them, some around both government as well as the Department of Defence, very active. And in Australia, there's a combination of federal funding. There's the decarbonisation fund. There's this new Future Made in Australia Act, which everyone's trying to work out how that where that is going to be distributed, as well as local opportunities as well. So look, there's a number of different areas. We haven't quite sort of decided on one. I think there's several that we'll be pushing, but there's some that are quite advanced, particularly in the US, that Steve's been working with, that are very close to Rice, and that's sort of a good partnership to really underpin our proposal. So we're hopeful that in the next 6 to 8 weeks we'll have a response on that. But you know, that would be quite a significant opportunity for us, I think. Steve, did you want to add to that?
Yeah, I think you hit the nail on the head, and you know, one of the key areas is just can be described as strategic sourcing, making sure that a number of the target critical materials can be processed and harvested domestically here in the US and in Australia.
Thank you. Next question is around the scale of the opportunity. You've mentioned a lot of different commodities and a lot of different potential streams that Flash Joule Heating can be used for. How do you go about, I guess, isolating one or two of those to really try and fast track? Or another way to ask the question is, which one of the end streams gets you most excited about the opportunity for Flash Joule?
I might just overlay there. We don't know what we don't know at the moment. I think there's some good testing that has been undertaken, but we're yet to nail down a commercial partner for it. Whereas we've got other areas which we weren't looking at, where we have a commercial partner knocking on the door saying, "Can you help me out?" So we're looking at a lot of different areas, and I think there'll be, if you think of a technology company that has several different clients, there might be some partnerships where it's a paid partnership. We're providing technology and a potential license. There's others where we'll be taking a lot more of a lead. And so I think we're working our way through to try to best avail ourselves of the best opportunities. And I think Michael put it quite well, is that lithium processing may be one of the best opportunities, and we really only just scratched the surface of that. So I think it's one of the challenges we discuss all the time internally is to try not to get too I suppose scattergun, but I think it's in an R&D phase predominantly. And I think when we came out with the technology from Rice, we weren't, and they weren't aware of some of the potential opportunities. So I think it's some groundbreaking stuff, and it might require us to just sort of narrow in, I think, as we go forward. But I think we may have several different partnerships, I'd call them joint ventures, underway with different companies on different specific opportunities that they've got, or that we can help them with.
Yeah, it might be worthwhile adding too that in our design of the 1 ton per day unit, we're taking care to make sure that we have the ability to handle different feedstocks and different byproducts. So we're taking that into account as part of the design.
Thank you. Just a reminder, if anyone's got a question, please just type it in and we'll ask that to the team. Specific question that's come in here around gallium. Is the technology potentially to be able to use to recover gallium from a bauxite waste? With a subset question there, is there any issues in terms of licensing the material outside of Australia and the US? So can you go to other countries, say Latin America, China, etc.?
John, would you like me to take that one?
Yes, Steve, yeah.
On the gallium front, we've done testing on e-scrap and some of the subcomponents of the e-scrap, and we see that good results there based on some of the things that have been tested at Rice University. We believe it is going to be applicable to other sources of gallium as well, although in terms of the traditional gallium processing, Michael, you might want to comment on that along the current pathway for red mud. I think that the Flash Joule Heating would be looking more towards sourcing from e-scrap, and then potentially as an enhancement to what's happening on the red mud side.
Just in terms of your comment, Craig, about applicability, we do have worldwide patents, so we are currently not looking into some other countries. It's mainly at the R&D level, but we do have the opportunity to go globally, and that might be that we partner with a major international processing company to then they might use the technology in their processing facilities globally, something like that, rather than us setting up in each country. But we do have a global license.
Thank you. Now, John, you addressed this earlier, but there have been a few questions, so just an opportunity again for some comments. Just an update on the exploration assets within MTM, and particularly, has there been any progression around the leases around West Arunta? Yeah,
sure. Look, we do have an exploration update coming out later in the month with the quarterly, but look, it's been a slow process in the West Arunta. It is an area where we arrived a bit later on the scene than some of the other players, and there is quite a long and arduous process with regard to native title and some of the access issues. So we haven't been able to get on the ground, so we haven't really been talking about it, I suppose, as much as we may have. We hopefully will get some a bit more light on that subject later in the year, which will see us be in a position probably early next year to get on the ground. But it is an area that I think there's a huge amount of opportunity. You've got not only WA1, but a few of the other majors. There's not only niobium, but other significant mineral opportunities. But for us as a small company coming probably a bit late to the party, there's some steps we need to go through before we can actually announce any news on that. So unfortunately, it's not a watch this space. It's we'll get back to you type of thing. But yeah, there's certainly with WA1 and some of their results, there's a huge opportunity in niobium and other rare earths up there.
Thanks, John. Last question, and it's probably a very early stage question, but you mentioned strategic partners and commercial arrangements. Are you able to discuss a little bit more what you're thinking about here? Is that a strategic stake in MTM? Is that a potential user of the technology, paying for some pilot testing? Just a little bit of the range of options that you've got out there.
Yeah, so I think Michael and Steve have been quite close to some of the discussions, but generally we're working at a technology level and a partnership at a project level to see whether our technology can assist, a bit like what Michael's talked about with the lithium, but as well some companies that have problems that could, they want to throw some technology ideas at them in a way of solving their issues, reducing emissions, reducing their waste, and so forth. We haven't really looked at strategics on the register, but I think it's fair to say if we did have some success, we would, I think, be a logical target for a bigger company to come on and want to be involved, but we're not at that stage yet.
Excellent. Thank you, John. That's all for the questions. I'll just hand back to you, John, if there's any sort of final closing remarks.
No, thanks, Craig, and thanks for setting this up. Appreciate everybody's interest and on the call. There's a lot of technical information. We are available for one-on-one presentations to follow up. So not on any particular schedule, but we're available to arrange particular follow up with technical or other people. So we'll be doing more of that as we go forward. I think there's a lot of new technical data and information to distill and to digest. So appreciate it's a little bit of a step in a technical direction, but we think there's some huge opportunities here. Some of the other comparable companies that have got Flash Joule Heating for graphene, for example, have a 10 times plus market cap that we've got. We're trying to pedal hard, and I think with some of the things we've got coming up, there's that potential to really step up to another level. So we're heading that direction, and hopefully you can join us along there. So thank you, everybody.
Yes, thank you.
Appreciate it.